Good evening, one and all. I am here to explain Shannon Fanon coding in digital communications, 5th semester ECE. There are two types of coding techniques, which is known as which we can know popularly as Shannon Fanon coding and Huffman coding. Now we are here to know about Shannon Fanon coding. In Shannon Fanon coding, there are four steps in the Shannon Fanon coding procedure. The first step is known as sort the list of symbols in decreasing order of the probability. In the question, we can get some probabilities of values with random numbers. Now we have to assign that probabilities in the decreasing order from top to bottom. And in procedure step 2, partition the set into two sets that are close to equiprobable as possible and assign 0 to the upper set and assign 1 to the lower set. Now we have to, after placing the probabilities in the decreasing order, we have to divide that probabilities into half and we have to check the equiprobable with less difference. Where if in this we know that we are dividing 0.4 and 0.2 as one set and 0.2, 0.1, 0.1 as one set. By adding 0.4 and 0.2, we can get 0.6 as the sum and 0.4 as the sum for set 2. So that we are having a less difference between those two numbers. So we are taking that upper one as upper set and lower one as lower set. So that we are assigning upper set with zeros and lower set with ones. In procedure number 3, we have to do that steps for all the individual until all the individual subgroups are formed. Now we are seeing that in stage 2 we are splitting that stage 1 0 0 to 0 1 and the lower frequency, the lower set in the stage 1 is splitted into two with equal equiprobability of 0.2 and 0.2 and assigning 0 as the upper set and ones for the lower set. In stage 3 we are splitting that equiprobability of we are getting equiprobability for the stage 2 with lower set and we are assigning as 0 1. In fourth step of the procedure we are assigning the code word as the binary values which is obtained in the each stages. Now we can take a problem that a discrete memoryless source has a symbols of x1, x2, x3 and x4 with probabilities of 0.4, 0.2, 0.1, 0.2 and 0.1 respectively. We have to construct a Shannon Fanon code for the source and calculate the code efficiency neta. By using Shannon Fanon coding procedure, we can form a table which we can see on the screen. We are assigning the probabilities in the decreasing order and the sum of the probabilities is equal to 1, which we know the formula is very well known formula. By adding all these probabilities, we can get their sum as 1. Now in stage 1, we are splitting that all the probabilities into two halves with the less difference between them. And we are splitting 0.4 and 0.2 as one set and 0.2, 0.1, 0.1 as another set. We are assigning the upper set with zeros and the lower set with ones. In stage 2, we are assigning 0 1 for the upper set, which is having 0 0 in stage 1, and we are splitting that lower set into upper set and lower set again and assigning 0 for upper set and 1 for lower set. Now here we are having 0.2, 0.1, 0. We can split that equally with 0.2 and 0.2. We are having 0.2 in the upper set and 0.2 in the lower set. So that we are assigning 0.1, 0.0 in the upper set and 1 in the lower set. For stage 3, we are dividing that lower set of stage 2 into equiprobabilities with equiprobabilities. We are having 0.1, 0.1. We are dividing that with equiprobabilities known as we can get the 0 for the upper set and 1 for the lower set, so that we can get the individual tables for all the probabilities. Now we are getting to the code word. In code word, we are taking all the stages values in the code word. For 0.4, we are getting the values of 00, binary values of 00 in the code word. For 0.2 with symbol x2, we are getting 0.1 in the code word. For 0.4, 0.2 with symbol x4 having the code word of 10. For 0.1 with symbol x3 having the code word of 110. For 0.1 with symbol x5 having the code word of 111. Now we are taking that number of bits per message ik as the code word size. We are having 2 bits in the 0.4, 2-bit code word in the probability of 0.4 with symbol x1. So we are assigning 2 for the 0.4. And similarly for 0.2 also we are assigning 2 because we are having the code word of 01 with 2 bits. For 0.2 with symbol x4 also we are assigning 2 similar to the previous one.
Okay, good evening, one and all. This is Tarun from EC department. Now I am here to explain about SHANNON FANO coding in by using MATLAB. Now we can do this SHANNON FANO coding in the online simulator, or we can download the software in your laptop or your PC. While logging into the website, now we can see the front view of the MATLAB software. After coming into the software, we have to create a new script in the left side of the window, which I have pointed now. After clicking on the script, we can get a new window here to see the which is used to type your code. Now after typing your code, we have to click on run, which is seen over there. Now I have already typed my code in the window, and I have saved as shannonfano.m in the extension of .m. Now I am going to explain about this code. In this code, we are using CLC, which is used to clear all the functions, and clear all is also same as CLC. Close all, which is helps to close all the unwanted functions which you have opened previously. Here in the line 4, we can see that enter the properties. This is used to display the output. See, we can get that enter the properties. We have given the properties of 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, and 0.04. After giving that inputs, we can get as we can get that in the command window, which we can see the output in the command window. For that, we are having some process which can be done to make a code board. This is the program for that process. Now we are getting a code board for 0.4 as 0, and for 0.2 as 0.011, and for 0.12 we are getting a code word of 0.1001, and for the code word of and for the property of 0.08 we are getting a code word of 1011, and for the code word of 0.08 we are getting the code word of 1100, and for the probability of 0.08 we are getting the code word of 1110, and for the probability 0.04 we are getting the code word of 1110. See, we have in the output window or the command window we can get the tabulation for the what we are given and the outputs. We are given the properties of 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, and 0.04. And the length of that is taken as the length of the code word here, which is given as this. For the probability 0.4, we are having a code word length of 1, and for the probability 0.2, we are having the code word length of 3, and for the probability 0.12, we are having the code word length of 4, and for the probability 0.08, we are having the code word length of 4, and for the probability 0.08, we are having the probability code word length of 4, and similar to the 0.08, we are having the code word length of 4, and for the probability 0.04, we are having the code word length as 5. Now, to find entropy h of x, we are using a formula is h of x is equal to probability into length, summation of probability into length, and we can get we are getting the answer as 2.4205 bits per symbol. Bits per symbol is mentioned is taken as the units of the entropy, and for the average length L, we are having the formula of P of x is known as a probability of x into log of 1 by P of x, and we can get the answer as 2.64 bits per symbol. Bits per symbol is known as the units of the average length, and the efficiency is taken as neta equal to h of x by L. H gives the 91.685 as the out as the result, and the redundancy is taken as the gamma equal to 1 minus neta. Neta is known as efficiency. 1 minus 91.6858 is results as 8.3142. This is the process of Shannon Fanon to do in the MATLAB simulation. Thank you. Thank you for giving this opportunity.